Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of April 13th, 2018, and we're looking at Venn diagrams and the real number system. Let's get started. Now, when we're looking at real numbers, this is a review, and the review of real numbers begins, I think, back when you all were in 4th or 5th grade at least, and it may have been even before that. So real numbers have been a part of your study of mathematics for a very long time. So I'm going to treat this like it's a review for everybody. All right, so if we're looking at the subsets of the real number system, we start with all the numbers, and then we have irrational numbers all over here by themselves. Then we have rational numbers, we have integers, we have whole numbers, and then we have natural numbers. And instead of looking at each problem one at a time, we're just going to sort these 4 numbers that they give us out into their categories. And remember, whenever you're categorizing a number, each number may belong in more than one category. And I've been saying in class, this is a lot like what we do in science. We can have an animal belong to more than one type of classification. So every animal has a kingdom, a phylum, a class, an order, a family, a genus, and a species, at least. In English class, you have some words that can serve as both nouns and verbs. For example, the word track. You could say, I am going to track an animal, or I am running on a track. It serves as both a noun and verb, so depending on how you use it, it could belong in more than one category. Numbers are the same way. So let's look at the list that they give us in the book. Here we go. We have 4 numbers here, and let's look at the first one, 0.050505. If you notice, that 05 repeats. The only category that a repeating decimal belongs in is a rational number. 0.05 repeating cannot be an integer, it can't be a whole number, and it can't be a natural number. Why? Because those 3 categories don't involve any decimals whatsoever. Let's move on to number 2. Number 2 is -1 times the square root of 64, and that's how I'm reading this. It says negative times the square root of 64. Think of it as -1 times the square root of 64. Let's see, -1 and then times 8. 8 is the square root of 64. -1 times 8 is -8. So we multiply those together and we end up with -8. Now where does that belong? -8, or the negative square root of 64, belongs in rational numbers, but it also belongs to integers. Okay, so that particular number has 2 categories into which it belongs. So moving on to the third part. This is the square root of 17. The square root of 17 is an irrational number. And the only way to figure that out is to take 17 and type square root. Use your calculator. The ellipses at the end of that number indicate that it goes on and on and on and on. We don't need to know how far it goes. We just need to know it goes on and does not repeat, and it doesn't end. So that's why we know it's an irrational number. The last number here is -3 1/4. Because there is a fraction attached to this number, it is a rational number, but that's the only category it belongs to. All right, that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.